In this video, we are going to solve a differential equation of the form y, the second derivative, is equal to the first derivative squared. Now, such a dE is always categorized as a second order differential equation. Yeah. Now, and this second order differential equation that we can name as dE is also in the term takes on the method called reducible to first order. Yeah, so it can be reduced to first order differential equation. Now, if that is true, we realize that if this is the case for such a method, yeah, so we have, but in such a case, if you have a second derivative with respect to x, yeah, and also you have an equation, the same equation, there is also the first derivative, and that same equation has y, they reduce to p dp dy, and also dy by dx becomes the p, and also y remains. So it reduces to such a form. Yeah. Now we go ahead and substitute them. We substitute them accordingly. So we shall substitute them in our dE. Where there is a second derivative, we put p dp dy, and also where there is the first derivative, we put p. So we go ahead and substitute. So we shall have y times p dp dy is equal to p square. Yeah, so remember the second derivative is squared, so we have p square. So when we divide through by p, yeah, when we divide through by p, we shall realize that the p's will cancel and we remain with one p. So we shall end up having y dp dy is equal to p. Now, if you look at this dE seriously, we can use separation of variable for the method to solve it. So there we can use separation of variables. Yeah, separation of variables. So so when we use separation of variables, separation of variables is like collecting like terms together. So we separate them. On separating them, we have 1 out of p dp is equal to 1 out of y dy. So the next thing that we go for is now to integrate on both sides. So we can go ahead and integrate 1 out of p dp is equal to the integral of 1 out of y dy. Yeah, so when you integrate 1 out of p, you end up having ln p. Very interesting. Math is very interesting and nice. So I have ln p is equal to ln y plus ln k. Ln k acts as the constant of integration because it is a constant anyway. So it acts as the c, the constant of integration. So we go ahead and simplify. So we can have ln p is equal to ln of ky, ln ky. Now, if we look at this is the same as p. So since obeying the laws of logarithm, p is equal to ky. Yeah, but remember p. What was p? Our p was the first derivative. So, but p was the first derivative dy by dx. This is how you defeat this number. This is how you defeat such numbers. So we shall have dy by dx is equal to ky, is equal to ky. So we go ahead and separate variables still. On separating variables and we integrate. So we separate variables. So when we separate variables, we are going to have 1 out of y dy is equal to 1 out k dx, yeah, so is equal to k dx. So we integrate both sides. So when you integrate on 1 out of y, you get ln y is equal to k x plus a constant of integration, for example b. Yeah, any letter the one that you want, you can use it. So obeying the laws of logarithm, we can write it as log base e of y is equal to k x plus b. Now you can write it in an indice form. Yeah, indice form. So we have y is equal to an exponential of kx plus b. Yeah, if you have reached this level and you have understood, please consider subscribing. And like this video. Yeah, like this video. So please subscribe. Subscribe, like the video, share it with your friend, and comment for anything you'd like to know. Comment. We meet in the next video. Thank you so much for watching. Thank you.